Hi guys, back again. I did a purchase a few weeks ago for one of these ER32 D14 adapters to go on the nose of my lathe, and these are great for doing small stuff. If you've got a big 3-jaw chuck and you're trying to work with that, it's sometimes hard when you've got 5mm stuff, 4mm stuff, and you're trying to machine it. It's great to be able to put it in one of these ER32 collets, up nice and close to the headstock, really rigid, and it's a nice way of setting up. Now, I purchased this from a local company who's new on the scene. He's about 45 minutes down the road from me, so he drop ships directly out of China, and I purchased this. One of the things I always do when I get tools is do your due diligence and do all your checks on it. Just make sure that the thing's concentric, it's all square, it's going to do the job that you've purchased it for. Well, let's just say I wasn't really impressed. I've set this up and I'll show you just how much this thing is actually out. It's atrocious. Before I do, I'll show you what the nose of my lathe is like, what the tolerance is like on that, what the run out's like on that, and then we'll mount this up and I'll show you what the run out is like on this. Now, what I have done is I've actually stoned the face of this just to make sure there are no burrs. I've stoned very, very lightly just everything on the nose of the lathe, just to make sure I've got nothing that's going to cause an issue when this gets nipped up. So yeah, we'll show you what the run out's like on this, and we'll show you what the run out is like on this. Alright, we'll do the nose first, and we'll show you the run out on that. Bring that up. Realistically, it's sort of like around about 0.05-ish radial run out, and we'll show you what the run out is like on the face. Now, the two critical surfaces on a D14 is that nose and this face here. So sort of close to zero, and that's actually nothing there, just the dial whizzing around. So I know that that face is spot on, and I know that that nose is concentric within 0.05 of a millimetre, so we're looking at a couple of tenths of a thou. So I'm happy with that spindle on the nose of my lathe. And when you're locking up a D14, they've actually got to lock up or locate on that taper at exactly the same time they pull up on that face. Realistically, there should be around about 1 or 2 tenths of a thou clearance on that face there before you engage the cams and lock it up, and it should pull it in hard, that last tenth of a thou, and then locate on that face there. So those are the two critical faces. Alright, we'll set up this D14 ER32 adapter, and we'll show you what the run out is like on that. Well, hopefully this is going to show it alright, but at the moment we're at the OD, up closest to the lathe, the nose of the lathe. We'll rotate that around, and that's showing 0.03 of a millimetre run out. Bring it back to the outer edge of that diameter. That's now showing 0.05 of a millimetre out, so that's quite considerable. While we're here, we'll just quickly show you the face. Hopefully you can see that, but I'll read out what the numbers are anyway. It's reading just a tad over 0.06 run out, and the important one, the nose Unfortunately, not going to be able to show you the dial, but I just have to tell you what that run out is like. And it's considerable. So it's 0.1 of a millimetre run out at the nose. So it's got progressively worse as they've machined. I'd say that when they've done the machine, the fixture that they've set this up in to do that machining has had some sort of swarf or a chip or something under that face when I've locked it up, and it's kicked it out and elongated the whole thing. So that's how it's machined. Now, I did contact the seller about this, and he was quite happy for me to get this sent back, and unfortunately it's not sent back to his postal address 45 minutes down the road. I've got to send it back to the drop shipping company over in China, and if you ever sent stuff over to China, it's a bit of a pain. So he was fine to send that back, and chances are I'd probably get one that's a lot better when it does come back. But what we're going to do is we're going to remachine this and get this back dead set concentric. So that when we do set stuff up here for machining, at least I'm confident it's going to be right. And what we're going to do is we're actually going to remachine that D14 using the AR32 collet with a bit of chrome bar in there to centralise the whole thing up, and then we'll remachine everything concentric again, get that D14 adapter side spot on again. So we'll break this down and we'll get set up for the machining. Okay guys, before we actually set anything up for machining, we're going to preset the angle on the top slide to match that D14 taper. Now the D14 taper is listed as 7 degrees, 7 minutes, 30 seconds. Now, trying to get that off the scale on the top slide is going to be near impossible, but there are other ways you can do it, and my preference is to use what's called rise over run. So 7 degrees, 7 minutes, 30 seconds actually works over at 1 in 8. So for every rise in 1, you get a run of 8. So I've set the indicator up on a parallel bit of shaft, which I've clocked, and it's pretty spot on. The chuck's pretty spot on actually, as a reference bar to be able to set that angle. I've also got another small dial indicator down here that I'm using as I move that top slide. I know how much I'm moving that top slide, and that's critical too. So you've got to work these two with each other. So what we'll do is we'll zoom up on this and we'll run you through that process and where we're at the moment. So for this I'm actually going to work in imperial, because the screws on my lathe are actually imperial and they have a bit of a dog arrangement where they go back to metric, and that's not quite right. So I'll be doing this in imperial. So what we're going to do first of all, I'll crank this back and we'll zero the top slide off. So it's zeroed off there. We're going to move this cross slide in until we get 0 on the indicator, which is there, and I'm going to zero out my digital readout on my cross slide. So now I'm going to crank that back just past 0.125, which is the rise over the run. So the run will be 1 inch and the rise will be 0.25. So we'll crank that back, we'll move this in 1 inch. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then back to 0. Now I'm going to move this in until I hit the 0.125 on my digi readout, and hopefully I should find that the needle goes to 0. Oops. 0.125, 1,258, 254, 250. Alright, so that's 0.250 right there, and I'm at 0.01 of a millimetre out. Now bearing in mind this is over 1 inch, and I think the land is roughly 8 millimetres, so we're 3 times, so it's going to be well below 0.005 millimeters out. So I'm happy with that angle that we've got set here now. Alright, I've locked all this up already. Be careful when you are locking up your top slide in that the dials do move around. You've got to even it out as you lock from one side to the other, and just balance that out so you maintain your 0, 0. Alright. The small indicator I might have mentioned at the back is so that when you do move your top slide, crank your top slide around, you know how much you're moving that top slide. That's critical, as I said. But as I said, I spent probably about 10 minutes setting this up to this stage, and I'm happy with that. So everything's locked down, and I'll get ready for the next setup. Alright guys, so off camera, I've put a bit of stock in the 3-jaw chuck, and I've turned that down to just a tad under 20 millimeters so that my ER32 collet's going to slip over that quite comfortably. And the beauty of actually machining it in situ is that it's dead true. It's dead true. You don't have to worry about trying to put bars in there and try and clock them up. If you do your machining locked up in the jaws, it will be dead true. So I can be confident that when I do put that D1432 ER32 adapter on there, that when I'm starting to turn that, it's going to be dead true. Right, so it's our D1432 adapter. I've taken the pins out of this. As I said, I've made up a number of these adapters in the past for all different types of chucks and fixtures that I use in the lathe. This is one I've made up in the past as an adapter, and I actually made up a mandrel out of a bit of old stock that was an old axle off an old crane that I got out of the scrappies. So I've made up a mandrel to be able to machine and fit this too. And try and fit that on there. But that will sit on there. It pulls up against the face and has absolutely no rock or no movement in that whatsoever. So that will be what we'll then reset this to after we've machined that D14 taper and we've machined the face. Now it's easier to machine that D14 taper slightly oversized and then machine off the face to bring the gap down, rather than trying to machine off on the taper. Tiny little bit off the taper makes a huge difference, not so much off the face. It's easier to machine the face last to match. So that's the way we're going to set this up. Alright, we'll get this mounted up in the lathe and we'll see how we go. Alright, we'll give that a good clean. I'll slip that on. I just want to make sure it doesn't poke through too much, or it's going to interfere with the mandrel. But I need to leave enough gap here at the front to be able to get my safety spanner in. Going to set the indicators up and just check all my runouts, make sure nothing's moved, and I'll just see how much that is out. Alright guys, I've got my old dial indicator here. Now on the face, right at the outer edge here, I've got a run out of 1/6 hour. And that will reduce as I go into the centre. So here it's measuring about 3 thou, and then when I actually get onto the inner diameter there of that D14 taper, it's measuring about 2 thou. So now quite a bit on that face, but we're going to clean the whole lot up, and that's going to be dead concentric to that ER32 collet. Alright, we'll get set up to get that machined. Alright, we'll have a go machining this. Now this is quite hard. Files won't touch it, so it's probably up around the 55, 58 Rockwell mark. When you're using carbides on hardened steel like this, you need the sharpest tool you can get, and don't run any lubricant, because what it does is reduces the friction and the tip just ends up sliding on the surface. So I'm going to try and run this without any coolant. We just have to feel for our speeds that we're going to run to. I'll just change that tip over. Righto, so I've just tightened the give up in this top slide. I've pulled the tool back a little bit and I've changed the tip over, and it's performing a lot better. So I'm just going to take one more little lick on that, and that'll be it. It's quite smooth. It looks worse than it is, but it is quite smooth. So I'll just give that a little touch with some emery paper, and I'm going to have a crack at doing this face. This is going to be a harder face to do with this intermittent cutting on this hard material, but we'll see how we go. We haven't actually removed any material, we've really just polished that. So that's a nice finish. I'm happy with that. Alright, I'll get set up and look at doing this face, and then we'll try and get our mandrel to be a neat fit. Alright, we've started an initial cut on this, probably cutting about half the face at the moment, and the finish isn't too bad, so we'll keep working away at it, very gentle steps at a time. We'll see how this tip holds up. You might change it over for the final cut. Alright, yeah, I've taken a bit off that tip, so I'll go off camera, swap the tip over. Looks like we're cutting pretty much the full face, but yeah, we've lost that edge on the carbide tip, so I'll just swap that over and then we'll take a final cut. Right, I've just taken a lick of that with the new tip on it. I'm just trying out the taper on this mandrel, and probably here there's just a little bit of slop in that. So I'm going to take a little bit more on that face just to bring it back a little bit further. much easier to machine it off the face to come to size than it is to machine it off the taper. 102. It's quite smooth. It looks worse than it actually is, but we'll try this mandrel on it now. Tiniest little bit of rock on that. I'll take another lick on that surface, but what I will do is I'll change this tip again. It's cactus. We'll save these for just normal mild steel, but on this hardness stuff, it's taking a good old hammering. So I'll swap that tip over again. I'll just take one more lick on that and see how we go. Alright, we'll come back up. This will be the last cut. Polish. Righto, we're back. We've done the final cut. I just glued up that taper in there just to match it to this taper here, and it's actually just gripping now. And it's probably hard to see, but I've got a high spot here and a high spot there, but the blue's even all the way around, so I'm very happy with that. Very happy with that. That's going to centralise beautifully up onto that. So what we'll do is we'll break this down. I'll clean it up, pop the pins back in. Actually, before I do, I might just machine the OD of this anyway. I'll cut the chamfer on the back there because I won't get a chance to do that later, because last thing you want is something that's a little bit wobbly. So we'll just give it a very light lick, chamfer and chamfer. Then I can machine that front face there when it's mounted up onto the nose. Alright, we've got this mounted up again. I'll just go around. See there. Our run out is now about 0.005 millimeters. So That has made a huge difference. When I put bar stock in there, that was running at around about 0.15. So from 0.15 down to virtually zero, that's a big difference. So it's worked out well. I'll just show you, I'll just zoom out a little bit if I can. How well this fits into place now. I might take the camera off, you can see that the blue is even all the way around, so I'll just do that now. So that blue is dead even. Nice, very light blue finish on that from the bearing blue. So really happy with that precision, and you know, that's absolutely spot on as far as run out goes now. So yeah, very happy with that. Alright, we should check this run out the way we started, I guess. So what I'm going to do, I'm just going to bring this up to 0. This will be the worst case scenario for the run out, which is right at the very edge. And it's at 0.01. So we've gone from about 0.1 down to 0.01 indicator run out. So as I said, when we put the bar in there, that dropped to half. So must be the way that's being held in the collets. So what I'm going to do next is I'm just going to lift that face up there, just recut that chamfer, and just face that off a little bit there to square it all up, and that's finished. So it took a fair bit of time to get that D14, but it's the sort of thing you've just got to creep up on. Just take your time, don't overcook it. And as you saw when I took that off last time, it was a nice nip fit on that D14 taper, and it was an even sheen all over with the blue. So not really happy with that final result. Alright guys, so we'll finish this off and we'll call this job done. Alright. As I did mention, you really need to have one of these mandrels made up, and you can machine these up and just match fit them to, you know, one of your spare chucks which has a D14, and get that and get a feel for that and get that absolutely spot on. So you really need one of these to continually check as you're machining. As I said, setting that taper, rise over run, 1 in 8. Now look, that's a great way of doing tapers for anything. If you can work out, just very quickly work out what the rise over run is, and you can set your top slide to any angle fairly precisely by using that methodology. So, all right, well, that's another tool for the workshop ready to go.